So now this is a record, the lecture is recorded. So if you raise questions, then your voices, your questions will also be recorded. Okay, so now we are going to first look at fundamentals of TCP and IP technologies.
Is there supposed to be audio?
Oh, sorry. So I guess there should be. Hold on. Hold on. Video, we are going to, can you hear me now? Explain.
Yep.
Okay, why we are concerned about security when we use internet. And in particular, we are going to look at some of the fundamentals in the internet that we are using today and why they cause security concerns. Okay, so why is security important? So when we talk about network security, we basically meant the security when we use internet to communicate with each other. Okay, so so if you see this bullet, first of all, internet is a public network. Okay, oh, sorry. And second, it is built on what we call TCP/IP technology. In particular, this is a store and forward technology. And so now let me open up a separate screen so that we can draw something up here. Okay, so TCP/IP technology. So this is it divides this architecture. So this network architecture is divided into 5 layers. Okay, at the bottom layer is a physical layer. So this layer transforms your content, so your binary strings, into signals for the underlying networks. For instance, if you're using fiber optics, that will become light pulses if you are using wireless network, and then the signals will be radio signals, and so that is the physical. So that's the physical layer. So let's say we have Alice, one of a user, and then the other user is Bob. Okay, so physical. So let's say this is a normal wired network. Okay, so this is connected. And it is so normally if this Bob is far away from Alice, this connection is not a direct connection. Instead, it will go through. So this is the internet. So it will go through a bunch of routers. Okay, so this is router A, and then you may also need to go through router B. So you would need to go through a few routers. Okay, and so now let's look. So these signals will go through these routers, and then this is a network layer. On top of it, oh, sorry, on top of it is a data link layer. Sorry. So this is a data link layer, and then on top of it is a network layer. So that's where IP sits in. So that it's internet protocol. That's at the network layer. And then, oops, where did I go? And then this is a transport layer. This is transport layer notation. Okay. Okay, so this is transport layer. So so the TCP sits at this layer and also UDP. So these are traffic control protocol. So this IP is for forwarding packets. Okay, so this is for packet forwarding. Okay, then on top of this transport would be application layer. So for instance, email, okay, web, surfing, and maybe remote login, SSH. So these are the common applications. So of course, for web, you have you can do online shopping, that kind of thing. So on the other side, it's the same. So data link, network, and transport, and application. So this is Bob's computer, it's host computer. So this is Alice. So computer is called a host. And a router only has 3 layers, okay, physical, data link, and network. Because it's a packet forwarding, so when a packet gets into a router, it just checks its destination and then it will forward to the next router. So one router may connect to different several routers. Okay, so it may connect to other routers. All right, so your email, for instance, you send a email, Alice sends a email to Bob, and that email, if it's long, then it will be divided into blocks, into data blocks. Okay, and then the data block will then be, so let's call this data block. Okay, let me erase this. Okay, so you got a bunch of data blocks because if the email is long, and then so when that data block goes down to the transport layer, so it will be just one block, one data block, and this is called payload. So that is one block of application data. Okay, when it goes down to this TCP layer, what it does is to add a TCP header. So the TCP header is used to control traffic. So then it means that, so it has, the most important part is two things. One is a port number, the other one is a sequence number. So we got port number, and also has a sequence number. Okay, you further down, so these are in here. Okay, you further down to IP. So it passes it down. Okay, so let me start a new screen. So that we have a better idea. Okay, let's say now we are using email at the application layer, and this is TCP IP. Maybe let's do a web here. But that's okay. So let's say now is a network. This is data link. And this is a physical. Okay, so you got a bunch of blocks here. So this is a data blocks. You can't just send a very long email in one shot. So you got to divide this long email into blocks such that each data block can be encapsulated inside a TCP packet. Sorry, this is not IP here. This is TCP. All right. So let's say this block comes down to the TCP layer. Then what it adds is a TCP header. And this data block then is called a payload of TCP. So in the TCP header, there's a port number, and there is a sequence number. Okay, the port number is used to indicate which program you are using. So you're using email, so you're either using SMTP or POP3, right? So these are the application. So you got a port number to indicate which one you are using. And then the sequence number is to link all these data blocks back. Okay, so so there's a so this whole thing pass it down to TCP. So this comes first, this comes second. So it needs a sequence number. At the destination, you can put them back in the original order because we are using store and forward technology. Some of the data blocks in a later part may come first, okay, may arrive first. So you need a sequence numbers to put them back. And also, in this header, it has other information such as sync. So this is for synchronization, and to go with synchronization, there is acknowledgement. So these fields, if they are set, so it's used to indicate, okay, so this TCP is for synchronization, and the other, if this ACK bit is set, then it indicates that this TCP packet is for acknowledgement of SYN. So, so we have this idea of three-way handshake protocol. That's how connections are made. Okay, so then we need to forward this packet into to the destination. So that means I'm gonna pass it down to the network layer. So this part is the same. So this is a TCP header, and this is the data block. And then this is now we are adding a IP header. So this part is a payload of the IP header. So this is the payload of IP, sorry, the payload of the IP packet. So each of these is called a packet. Okay, so in this IP header, the most important thing, two things you need to forward this is, you know, the destination IP, and also you need a source IP address. Okay, so these are the IP address. So then this one comes down to the data link layer, what you are getting now. So you got IP header, you got TCP header, you got a data block, and then you got a frame header. So this now is called a frame. So let me put this IP. So this is the source IP address, and then we got a frame header, and also it comes a frame trailer. Okay, so a trailer tail. So let me use a trailer here. Let me use a trailer. Frame Okay, so so now this is hardware dependent. So depending on which IEEE 802 technology. Okay, so it's hardware dependent, so it depends on the underlying network you are using. And these three layers are logical layers. Okay, so which means that they are hardware independent. They are just software. Hardware independent. Okay, so then these will then become signals. So this is just will become signals, physical signals. So you need a beginning to indicate, okay, this is the start of a transmission of this particular frame. You need an end to indicate this is the end. Otherwise, they are all just signals. You don't know which one is the beginning, which one is the end. Okay, so you do need those. So this is physical signals. All right, so now let's move back. So now let's move back. So if Alice wanted to send an email to Bob, okay, so his email will go down in this direction. And then finally, this packet will go through. Using the internet technology, that means that the packet will first go to a router. So we call this intermediate router. And then depending on the destination, it may go through the next router here instead of going this router, right? Because this is further away. And then you keep going and then going to the last one, and then you go into Bob's machines. So when the signal goes to this machine, then it will first be converted back to a frame, and then it will convert it back to a network, to an IP packet, and then it will convert it back to a transport packet, TCP packet, and then you will convert it back, which means when you go through the network, you take off the header, you get a TCP packet, you take off the TCP header, you get the data block. So data block will go back to the application. All right, so basically that's how a packet is transmitted from the sender to the receiver. So now what we are interested in is this internet, right? So your packet goes to this router. But who controls this router is not Alice, okay? It's not anybody Alice knows, actually. So this will be controlled by a third party. You may not even know them, okay? So what that means is now because this internet router has these three layers, so which means that they will have your IP packet. Okay, so they have everything, right? They have everything. They can look at your IP packet, and they can also look at the protocol that packet is using, and hence anybody can see the payload of that packet. Okay, so again, this whole thing is a packet. This is a payload. This is TCP. This IP. So if they if the third party also install software to read this payload, then they can read it. So now we see the first security issue we are facing is that the email sent out from Alice to Bob can be seen by any intermediate routers here. And so you don't have privacy. And another one is that a attacker may be able to modify your packet. So let's say this is a bad guy. So this attacker gets your packet and he modifies the payload and continue to forward to the next router as if this packet comes from Alice. Okay, so you can see that because of this technology, so the things you sense through the internet is wide open. Okay, so this is like you open up, so you send a mail, and that mail can be read by anybody. Okay, so by any mailman, for instance. Okay, so this is a security concern, obviously. So that is why we need to have mechanisms to protect the information you send over or send through the internet. Okay, so that's what this course is about, what type of mechanisms we can use. So in order to address these mechanisms, so we will need first look at some of the common network security attacks, okay? And then we'll provide a network security overview in this chapter. So then after this chapter, we will talk about concrete security countermeasures, the mechanisms we use to secure network communications. Okay, so that is why network security is important. We now look at the mission and definitions of network security. So first, we know that network security is to protect our communications. Our communications are considered as data in a very broad sense, which means that any object that can be processed or executed by a computer is a data. Hence, a data includes a text file in any kinds of format. Data can also be a executable file, a program, a graphics file, and an audio file, a video file, and so on. So in general, anything that we can send over from one computer to the other is a data. Anything we can process using a computer is a data. And anything that we can execute on a computer is a data. Okay. So then data has two states. One is called transmission state, which means that the data is in the network for transmission. So it flows from one router to the other. So it starts from a computer, going to the next router, going to the next router, and going to the next, and so on, until it reaches the destination, which is a computer. So during this time, we say that the data is in the transmission state. Okay. And the data can also be in a storage state, which means that it is on a computer. Okay, it is not on a network. It is stored on a computer's hard drive or main memory. So that data is in the storage state. The missions or tasks of network security has the following things that we need to provide. The first one is data confidentiality or privacy. So we also call it privacy. So of course, privacy includes data in transmission state and in the storage state. The second task is data integrity. This means that data integrity means the data cannot be modified, fabricated, or injected during transmission or at storage. Okay. And data confidentiality means that your data is well protected so that nobody can see what your data is without permission. Okay, so only the user who has permission or legitimate who is allowed to see the content of the data can see it, and nobody else should be able to see the content of your data. So that is data confidentiality for both states, okay? For data in the transmission state and for data in the storage state. Data integrity means that the data has to be in its original form. It has not been modified and it has not been fabricated. Okay, so you cannot create a data and point to somebody else that this data belongs to that person. Okay, so that is fabrication. So that's data integrity. The third task is to make sure data cannot be repudiated, meaning the owner of the data cannot deny ownership of that data. Okay. And the last task is data availability. So this means that data should be available when the data is needed. So again, this is also for data in the storage state and in the transmission state. Okay, so the things we need to deal with would be the followings. We know that network communications following network protocols. So the design of protocols may have loopholes, and implementation of the protocols may have side effects, flaws. So those issues, okay, may harm the security of the network communication. So in our case, loopholes, flaws, and defects are exchangeable terms. Sometimes we say loopholes, sometimes we say flaws, and sometimes we say defects. They mean the same thing. Okay, so then by law, to provide network security, we can only be passive. In other words, we can only provide passive defense for network security. We can set up mechanisms to set up a nasty defense lines to protect our data. And we are not supposed to attack other people, to attack others for our security. For instance, if we know an attacker who attacks our machine, who attacks our data, because the data is what we try to protect. And we are not supposed to attack the attackers right back, because that would be considered unlawful. So we can only provide passive defense. And in addition to the network security, there is a much broader areas of cyber security. Sometimes we call it information security. So cyber security includes more than just what network security. Okay, it includes, for instance, software security, database security, emergency response, and some others, and trusted operating systems construction, right? So these are all considered as cybersecurity or information security. So network security is a major part of it, but it is not the entire thing. Okay, so cybersecurity contains more than just one network security. So this is a broader scope that I would like you to keep in mind. All right, so that is the definitions and tasks of network security. In this course, we are going to present we are going to present all the mechanisms to provide network security. We'll be first talking about secured network security protocols. In order to talk about network security protocols, we need to make certain preparations of the building blocks for making network security protocols. So these building blocks are cryptography, including data encryption algorithms, key generations, and public key cryptography, which is used for key distributions and for data authentication. So these will be our building blocks for making network security protocols. Okay, so after that, we are going to talk about security perimeters, or people sometimes would call it firewalls, or often call it firewalls. And we are also going to talk about intrusion detection systems. And finally, we're going to talk about anti-malicious software. Okay. So that's what this course is going to cover. Now let's look at common attacks, common network security attacks, and defense mechanisms. Okay, so the first attack is eavesdropping. As we saw in the previous video, that internet we are using today is a public network. That means that any communications between two remote parties will have to go through routers controlled by the third party. Okay, so any data that you put in the network will have to go through other routers, and so that means any router. So that means on the path of your data from the source to the destination, on that path, any router can see your packets, your IP packets. Okay, so what you need is a common packet sniffer to find out what the contents of those packets are. For instance, you can use Wireshark. Okay, so this is a common network packet sniffer. You can also use TCP dump. Wireshark has a GUI interface, so which is a very convenient tool to use. Of course, it can also be used. It can also be used to to analyze network traffics. Okay, and the solution to counter eavesdropping attacks is to encrypt your data. Okay, so that the routers on the path of your data won't be able to see the true content of your packets. The next attack is cryptanalysis. So this attack is targeted at the underlying encryption algorithms and key generation algorithms and management. Okay, so the purpose of cryptanalysis is to find useful information from encrypted data. For instance, one of the analysis would be to find out if the encrypted data has any statistical structure, because that statistical structure may reflect the same structure of the original plain text. Hence, a mapping could be made. So the defense mechanism for cryptanalysis attack is to make sure this analysis conducting such analysis will be difficult to do. So for instance, you may want to use longer keys and stronger encryption algorithm. And of course, you need to manage this algorithm, and you need to have a robust implementation of these algorithms and manage these algorithms well. Particularly, you need to have a good data structures, to store your secret keys, okay, and manage them. The next attack is password pilfering. Okay, so for any authentication to be done, the common mechanism is username and passwords. Okay, so this is to authenticate a user is legitimate. So password protection is often the first defense line, which may be the only defense available in some system. Okay, but nowadays, for instance, you have other mechanisms to authenticate users. On your cell phone, you could have a retina scan, fingerprint scanned, and you can, maybe there are some others, right? So facial recognitions, that kind of things. But passwords are still the commonly used authentication mechanism. So the methods to steal or pilfer user password would be guessing, okay, social engineering, dictionary attacks, and password sniffing. So we're going to look at each of these possible techniques. Okay, guessing is the easiest way okay, so my time is up. So so our lecture time ends at 3:15. So if you have time yourself, you may want to continue, finish up this video, and of course we are going to resume this video on Wednesday. Okay, so are there any questions for me at this time?
I'm good.
All right, then I'll see you on Wednesday. Oh, by the way, I have office hours from 5 to 6 in case you have any questions. All right, so see you on Wednesday.
All right, thank you.
Yeah.
Thank
Bye-bye.